So 3-2 today is completely talking about linear equations. Okay. Last time we graphed linear equations, did we not? By using their y-intercept or points or other things like that. But we are going to be going ahead and graphing them and writing equations of linear equations. Sorry, Doug. Thank you. Where are you? That's a rocker copper. Aren't you excited? Okay. So, with that being the case, 3-2 is lines with slope. That's what basically we're going to go with today. So we have our two cases. Remember, we have y equals mx plus b, right? Which we talked about last time. Once again, what is the m standing for? Slope, right? And the b stands for what? Y-intercept, okay? All right. So if I give you a slope and a y-intercept, writing our equation is fairly simple, isn't it? Okay, for example, if I said our slope is 2 and I have the point 0, comma, negative 3, okay, isn't that our y-intercept? How do I know it's our y-intercept thing? X is 0. Remember, y-intercept is when x is 0, correct? Okay, so with this being said, this is slope and a y-intercept, so I can just plug and chug, can't I? With that, here we go, y equals slope 2m minus 3. Right? Pretty self-explanatory. Okay? But, am I going too fast? I don't want to. Okay, awesome. Going on then. Nobody said anything. Okay. So what if, though, not every time do we give you your y-intercept, do we? Let's say I give you the point 1, comma, negative 5. Okay, but I do tell you your slope is negative 4. First off, let's go ahead and graph this. Okay, go ahead and graph this. So I have the point 1, negative 5. But we have our slope being negative 4, right? What's underneath that negative 4 even though he's not there? The 1. And we also need to recall what is slope. What did we say it was last time? It is rise over run. Now, remember, I could do negative 4 over 1, or it could be 4 over negative 1. Once again, those are the same idea, correct? So I'm going to start here at my point. Okay, I can either go down 4, 1, 2, 3, 4, run 1. What else could I do? I could go up 4, 1, 2, 3, 4 over 1. Now remember, if you recall last time, I asked you for how many points unless you're in standard form. I want 3 points on my graph, right? And I could continue on to make it a little bit nicer, but I'm not going to.
If you have
once again, if we're in standard form, we should be okay, right? You know, but if not, let's see. Okay, there it is. Nice, huh? Okay, here, luckily, my y-intercept's pretty nice, isn't it? What is my y-intercept? Negative 1. Does everybody see that? How it's crossing? There is actually a point that's on there, but does every graph cross the y-axis at a perfect point? No. So on this one, we could write the equation if we wanted to. Y equals our slope being what? Negative 4. X with our y-intercept being negative 1, because we graphed it and we looked at what it was. But not every case is that situation. So I'd like to show you guys using this same information how we can get to that exact same equation. I believe I have 1 comma negative 5. Is that correct again? Is that what I have? And my slope was negative 4. I'd like to show you guys point slope. Okay, that is an equation that we can then go ahead and turn into our slope intercept. I prefer you to keep going. I don't know what the textbook says, but I believe you should keep going. Okay, here is your equation. Y minus y1 equals slope times x minus x1. This is called point slope. When do you use point slope? When we give you a point and a, oh my hell, it's so easy. Tells you exactly what to do. Okay? Sometimes if you just say what it is, it'll let you know what you need to do. By the way, I'll show you where this formula comes from in just a second. Oh, yeah. So, what this x1 represents is the x value of your point. The y1 represents the y value of your point. So, it's just a plug and chug situation, isn't it? Okay, here we go. Y minus, who's my y1? Negative 5, so I have a negative negative 5 equals our slope, which is negative 4, parenthesis, x minus 1, correct? Because once again, x1 is negative 1 up there, correct? Are you good with that? Any questions on where I got that from? I heard you gave a speech last Friday. I don't know how you did, but I heard you did. Okay. Y minus a minus 5 becomes what? Y plus 5 equals negative 4x. I'm distributing through. A lot of time, as I even noticed on your guys' test, okay, everybody should have your test score. Hopefully check skyward, it's on there. Okay, as I distributed through, some people distributed to the first, but they forgot to distribute to the back. I think there was about 10 to 15 people overall out of both classes that did that. Forgot to do that. So remember to always distribute to both, right? So with that being the case, that becomes a plus 4, isn't it? Is y by himself in terms of y equals mx plus b. We got one more step to go. The last step would be to do what? Subtract the 5. So I have y equals negative 4x, 4 minus 5. Guess I could show that. I struggle with showing the steps. Oh, so easy. But is that the exact same equation I had on the previous side? Now, the other side, let's be honest, was a little bit easier, wasn't it? But I had to graph to find that y-intercept because I didn't have it given to me. You guys agree with that? It wasn't given to me, so therefore it isn't there. Good? Yes, no, yes, no. All right. So, what if, though, you get equations that say, all right, I'd like you to plot this graph. It is a line, plot a line, I guess I should say, between the 2 points, 2 comma 3, negative 4 comma negative 7. And there's all slopes going to be nice numbers. Sometimes they might be fractions, right? Fractions are part of what it is. You got to learn how to work with them. So we're going to plot the point, and then we're going to write the equation. How are you again? Or did you come back? I don't know. Never mind. How are you? I think you're in the wrong classroom, sir. This one said T2. I don't know who that person is. All right. So we're going to plot first. 2, 3. Everybody feel comfortable there? Plotting the point. -4. Okay, and I'm just going to go ahead and draw the line in between them. Now, first off, I just did this by hand. So does that mean exactly that's where my y-intercept is? No, because once again, I'm sketching this the best I can, correct? Does everybody agree with that? So it looks like roughly a half, but I don't know. Well, what can I find via plotting 2 points? Because I need to write an equation, don't I? What could I use? Well, isn't slope rise over run? Correct? So I'm going to say, okay, well, I'm here at -7, and I'm coming up all the way over to 3. So how much does it rise from -7 to 3? That's a rise of 10, right? Now I ran from -4 all the way over to 2. So I ran, or run, whatever, rise over run, right? It's ran. 6. So first off, what's my slope? So once again, because it is rise over run, 10 over 6, but do I like 10 over 6 in mathematical terms? What should it be? 5 over 3. Okay, that would be our slope. Could I write an equation of a line? How do I do so, Miss Williams? Because I don't have my y-intercept. I have a slope, though. What else do I have? Point. What formula am I going to use? Point slope, oh my God. Okay, always between 2 points, can we always find a slope, right? Okay, another word for slope is called average rate of change. Another definition or another name for slope is average rate of change. Because in our story problems, sometimes they ask you for an average rate of change. Okay? All right. So, just as Miss Sydney Williams, no, not Sydney. Did I get Williams right? Did I get the S right? What is your name again? Way off. I apologize, Rachel. Okay? So just as Rachel said, we have a point and a slope. You guys have your point on top of there, right? I had the point once again, 2, 3 and -4, -7. Am I right in that? Those are my points, correct? Okay. And then I have my slope of m equals 5/3. So I found that. Okay. Now, does it matter which point I pick? It doesn't. Doesn't matter whatsoever. So I'm going to pick this guy because in my mind, remember our equation is y minus y1 equals slope times x minus x1. He's my x1, he's my y1. Or x2, y2. Does it really matter though which one? Not really. Okay, so it's a plug and chug situation. Here we go. Y minus 3 equals slope times x minus 2. So if ever in your book they ask you, or in your homework they ask you to put it in point slope form, do I have to go any further than this? Nope, I'm done. But I prefer that you put it in slope intercept, which is y equals mx plus b. Okay? So we're going to continue on. Really quick though, how do I go ahead and multiply fractions? Straight across. Okay? Key thing there. Here we go. So I have y minus 3 equals 5 thirds x minus, straight across. What's underneath this 2 even though it's not there? 1. 5 times 2 is 10. 3 times 1 is 3, so I'm at negative 10 thirds. Okay. So now I need to go ahead and solve for y. How do I get him over to the other side? Add 3. And because he's 10 thirds, right, I'm actually going to be adding 3, which is 9 thirds. What did I do there technically? Times 3 top and bottom, didn't I? To make it still another representation that has a common denominator, correct? Look at my y-intercept. It should have been where? Negative a third. Did I even get close on my graph to crossing at negative a third? I think I was more out of half, right? That's why you can't really always judge something by a sketch of a graph, right? Now you good? Okay. All right, Hippo, I like you. Okay, I would like to show you guys once again using these 2 points again. 2 comma 3, negative 4 comma negative 7. Our slope was 5 thirds, correct? So instead of always having to plot the points and doing a graph and rising and running, what's another way that I could have went ahead and just found the slope? Does anybody else know what's the difference? What's another definition of slope besides rise over run? Average rate of change, that's very correct. And we can talk about that. The rate of change means the difference of our y's. They change it like this. It says the change of our y's over our change of our x's. If you've ever been in a physics or a chemistry class, the triangle means change. Okay? Has anybody ever seen those before? Yeah. Okay? So it's the change of y's over the change of x's, which is y2 minus y1 over x2 minus x1. Should I do x1 minus x2 over, excuse me, y1 minus y2 over x1 minus x2? The key thing is you just got to keep them in the same order. Right? Okay, so where did point slope come from? Remember, this is slope, which is m, huh? Anybody see where it's going to come from? Just times this guy up here. But notice on point slope, we only have 1 point. So therefore, instead of these 2's, there's our point slope. Point slope comes right from the slope formula. So if you ever get lost, you come right from it. Now, how many of you teachers showed point slope in the past? You guys remember doing point slope? Some teachers like to also show, I'm going to show you just one other way. I just want to give you guys ideas that you can do any way you want, because there's many different ways. Some teachers also just show this. Y scumbag equals mx plus b, correct? Okay, what was our slope? We already found it. What was it? It was just 5 thirds, wasn't it? Not negative 5 thirds. Okay, so what if I did this? What else did I have? I had a point, didn't I? Correct? Well, that point has an x and a y value within it. Agreed? So what was an x value I could plug in? I could plug in 2, couldn't I? What was the y value that associated with x being 2? And notice I only have to solve for b, and then I have it in the substitute back. You see how you can work either way. I don't care how you do it. Many different people, many different ways. Okay? So this is 3 equals 10 thirds plus b, which 3 is the same thing as 9 thirds, correct? How do I solve for b? Subtract it. B is negative a third. And then I just come up here and go, this way. Is that the same equation as I have here? Right? We good? I just want to show you multiple ways to get to the same thing. So notice we either have A, if we have 1 point of slope, just jump right in. I like point slope. I prefer that over doing this, but that's how I was taught. But this is just as easy, okay? But I like the other way because it's very self-explanatory where it puts stuff in. Okay? Let's go ahead and do another one. Okay. Okay, so let's do these guys. If that door is bothering anybody being open, you're more welcome to do it, but I don't mind. Whatever. I have 2 points. Here we go. How much are we rising? Well, let's try our slope formula this time instead of plotting them, okay? So I have slope equals y2. Who are we going to call our y2? Let me call him y2. So if I call him y2, what's this guy? 6 would be x2. I'm going to call him y1, and he's going to be x1. Okay? Really quickly, notice I have m equals y2 minus y1 over x2 minus x1. What do we get? 0 over 3, which is 0. Does anybody remember from last time? Because we did talk about it. If your slope was 0, what kind of equation? Is it a vertical line or was it a horizontal line? Horizontal, because once again, we are not rising, but we're running, aren't we? Correct? That's okay to happen. What's this one doing? We're rising, but are we running? And that's a slope of undefined, right? Does that make sense to everybody? The difference between the two? So this slope is 0. What equation are we always going through? It was a pretty self-explanatory one. What value are we always going through? 5. Is it y or is it x? What axis would this go through? What number would this always go through? Not axis. What number? I'd always go through the y at 5. Right? Doesn't matter our x value. This is just y is 5. And we could do point slope on this one just as well, just to show you. Y minus y1 equals slope times x minus x1, which is 3. What's 0 times anything? 0. Y minus 5 equals 0, hence y equals 5. It still gets us there, doesn't it? What you smiling about, Flo? It is a good day, huh? Okay. What would it look like if it's a vertical line? Would the y's be the same or the x's be the same? So you'd have like 3 comma 2 and 3 comma negative 1. Right? Yes, that's because it's vertical. Because no matter what your y value is, what's your x value? In this case, our x value is always going to be what? 3, right? But we can do our slope just to show you. Let's check our slope. y2 minus y1 over x2 minus x1. And notice that shows that it's undefined. Hence why our slope is undefined, hence we know it's a vertical line going through the x-axis at that point. Okay? How do you get them up like that? Just curl them tight and put it up in there? We never had no material. Okay. Let's see what else we got. Hello, young lady. How are you? Let's go ahead and go to your homework page because I'd like to do an example off of this one that we're not going to be probably using. Let's do, you guys choose 19 or 20, I don't care. We'll do that one on the board. 19 or 20 on 3-2. 20, we have one for 20. 20, I got 2. 20 it is, there we go. So we're going to look at this example. Now, once again, you're looking at number 20 on 3-2 of your homework. And I don't have it plotted up here, but everybody should be able to do this because it's given to you currently right there, correct? Okay, so looking at number 20 of your homework, here's what it says. Okay? Number 20, it says, the following data represents the number of public community colleges in the United States from the years 1920 to 1990. Plot the ordered pairs, X, Y on the graph, connect the points with a straight line. Okay? First thing I would do here, ladies and gentlemen, is I really don't want to go ahead and state 1920. 1920 to me is going to be representing my 0. So I say that somewhere. So therefore, what would 1930 be? It'd be representing my 10. Does everybody understand how I would want to dictate that so I actually have an accurate graph? Because if not, when you do your graph, technically you're supposed to have increments of something going all the way from 0 up to 1920, right? But if I indicate that that's going to represent 0, then we're good to go. Does that make sense to everyone? Okay. So on my plotting, I think we went from 0 all the way to what? 19 what? 90, so what would that be? 70, because that's 70 years different. You guys agree with me on that? So we have 10, 20, 30, 40, 50, 60, 70, which would represent 1990. You could also put that if you wanted. Okay, so we just plot our points. On the right, I'm probably going to go increments of 100. Now, once again, I'd say that's 1300. Just kind of do your axis really quick, just so you understand where it's at. Okay, we're going to hurry and plot these. So at 70, roughly right here. 178, somewhere right there. 258, roughly in there. 337, somewhere there. 390, there. 847 there, 1049 and 1282. Not too hard to plot the points, correct? We could all do that. Okay. Now, it says compute and interpret the average rate of change in the number of public community colleges between 1920 and 1930. So once again, what is average rate of change? Just another name for slope. Okay? So really quickly, last time on this chart, okay, this was the year, and what is this story? This is community college, right? Okay, at 1920. How many was there again? 78, is that what it said? 70, 70. How about 1930? 178. Okay. Ladies and gentlemen, how many of you guys have ever found slope via a chart? Pretty simple, right? All we have to do is say, okay, how does 70 get to 108? It went up by 108. What is that called, ladies and gentlemen? That's our rise, isn't it? Because notice that's in terms of our y values, correct? By the way, Eva, you sit over here. You can stay there for that. How much did we run? 10. So what's our slope or average rate of change for those years? 108 divided by 10, which you could break it down to 54/5. But notice, that really doesn't represent really what we're talking about. I would like that for a slope purpose, but that would be 10.8. Right? This one's okay to be in decimal, just because it talks more about what's happening. It's saying, on average, every year, we're increasing 10.8 community colleges per year. Right? We started at 7, B, 70, and we went all the way to 178. Over that average rate of change is 10.8 community colleges per year. Correct? Okay. Part B says, average rate of change, excuse me, part C says average rate of change from 60 to 70. Can somebody tell me how much is in 60, please? 390. How about in 70? 847. Okay. Now, if it is linear, that means they would have a constant slope throughout, correct? Yes, no? Obviously, we can tell it's not linear because it's not straight line from our plotting, correct? But let's go ahead and find the average rate of change here. Okay, that is 457. How much should we run again? 10. So if we did 457 divided by 10, what do we get this time? So once again, between these two, does that dictate that this is a linear data? It might be linear for a little bit. Right at the beginning it was linear, right? And then all of a sudden, maybe in the 1960s, 1970 type era, maybe the population thought education was more important at that time, so there's more community colleges being built, right? You think about like my grandparents barely graduated high school, right? Maybe the need for community college wasn't there, right? Whereas maybe people started interpreting that education was more important, or that they needed those jobs to maybe succeed a little bit more. I don't know, you get what I'm going at? Maybe those start popping up a lot more, okay? That could be internalizing our data, right? All right. Part D, compute and interpret. Now, holy crap, you get the average rate change. Ready to keep doing that? You okay with that? I'm not going to keep going now. Based on our results, do you think this is linearly related to the year? We can already tell no because it's not constant. Now, what if it was pretty close? What if this was 10.8 and this came out to be 10.4 and the next one came out to be 10.6? Is that pretty linear considering data? Not exactly linear, but it's pretty darn close, isn't it? Could we recognize that being more linear if it was in that facet? But that big jump from 10.8 to 45.7, no, it doesn't really help us out. You have to kind of think a little bit different when it comes into real world analysis, right? If it was more something around there, that's pretty darn linear. They're not exactly the same, but it's close enough, right? So we can dictate it as represented. Okay? Any questions there?
Just making sure I've covered everything.
That's it. Okay, so you guys have the remainder of the time. So you're doing just 3-2 today. I'm deciding what I would like. Okay. I do want you to do the odds, but I'm going to add a couple of them just to make sure you guys get a good recognition of what's happening at some other problems that might be a little bit different. So I'd like you guys to do 24 as well. 28. 40. And that should be good. So we're going to do the odds, but adding those 3 extra problems as well on 3-2. Okay? Does that work? Does the answer sheet still have 3-2 within it? Yep. Is that the last section? All right, we got 3-4. I'll make sure you guys get the rest of the answer sheet by next time. I just haven't finished it all. Okay, we good? Okay, you guys have roughly 20 minutes, which is unusual to have in the class time, right? So go ahead and work on that. Make sure you're doing the work. Here we go.